For this last example, we need to assume that this is talking about current time. I will preface this by saying that I think the data is actually from the year 2013, but for the sake of being able to move forward with this, we're going to pretend like it is current. Right now, the world's population is 7.1 billion people. It is expected to grow at a rate of 1.1% per year. What will the world's population be next year? Before we answer that, it might be helpful to go ahead and get some of the other information on the chart. So let's skip ahead to the next one. What is the multiplier? So we're taking 100% of the current population and adding to that 1.1%. That's 101.1%, which will translate to 1.011. Our multiplier is 1.011. If we say the current year is year 0, what would be the equation? When we're using year 0 or 1 or 2, we're just filling in the table, kind of like the previous example. This is the equation where we're plugging in our A value, that initial value 7.1 billion, and then putting in our multiplier, and then just leaving x in the exponent. And again, whatever this number is, it is in billions. Okay. If we use the actual year as input, what would be the equation? Remember, this equation is going to look really similar. 7.1 for our A value, 1.011 for our multiplier, and then you would take x and subtract whatever the current year is. And since the current year is 2018, I'm going to go ahead and plug in a 2018 for this. And again, whatever number we come up with, it is in billions. So going back to the first question, what will the world's population be next year? You could use either one of these formulas. We should arrive at the same answer either way. But I'm going to take the first one, and for the exponent, since we are looking at just the next following year, it's going to be a 1. And when we calculate here, we should end up finding that we're left with 7.1781 billion people. So there is an increase there. Last part, if this trend continues, what will be the population in the year 2050? Right. So since we're talking about a specific year, I'm going to use the formula that uses years in the exponent. Y equals 7.1 multiplied by our multiplier 1.011. And then I'm going to plug in 2050 so that x value is representing whatever year they're actually looking for. And I'm going to subtract from that the current year. So I'm subtracting from that the year 2018. Right, so I'm just going to do a quick calculation over here. We're talking about a difference of 32 years. So we're going to use an exponent of 32. Y equals 7.1 multiplied by 1011 to the 32nd power. And if I go ahead and do my calculation here for this, we will have 7.1 multiplied by 1.011 to the 32nd power, giving us approximately 10 point, I'm going to do a little rounding here, 0.8 billion people. So the takeaways from your notes portion of this really would be the formula, what the variables in the formula represent, how to find the multiplier, and then just when to use each of the two versions of this. So from this one example, I'm just going to go through and kind of highlight a couple things for us here. When you're looking for multiplier, remember it's always 100% of your original amount, adding to that the rate that's going to be provided, and then converting this percentage finally to a decimal. So your B value in the formula, the multiplier, will always be a number greater than 1. The next part that's really important would be just your layout for the formula itself. Remember, it's always y equals. We are talking about functions still, so it's going to take on that kind of function template. The difference between this and what we were doing before is that these are not linear, they are exponential, so we can expect for this to start looking a little bit different as we get further. That first value, the A value, represents year 0, or the initial information that's provided to us. The B value is your multiplier. That's true in both equations. The difference between the two pieces and which one you might end up wanting to use in a problem is how you treat the exponents. You're either looking for a value, like a location on a table, like the first term, second term, and so on, or you're working with an actual year and it gives a specific year to solve for, and from that we would be subtracting the current year. Right, so it looks like different things happening, but these are essentially the same formula. They are flexible so that they can fit the type of problem that we actually have. Right? And then you're getting your final answers after you do the calculations here. When you start solving these, really important, and just as a side note here, keep in mind that you do need to use order of operations. Keep in mind that this exponent only goes with the multiplier. So you should raise your multiplier to the power first and then finish this out with the multiplication. Right? So order of operations is still very much relevant on this. We want to make sure that we're doing things in the right order.